Good morning students and welcome to 25th video lecture for class 11th chemistry chapter 10 S block elements, and today we are starting with some important compounds of sodium. In this we are starting with sodium carbonate. Now soda ash or washing soda Na2CO3. Now on commercial scale, sodium carbonate is prepared by Solvay process or ammonia soda process. This process is based on the fact that sodium hydrogen carbonate, the formula goes NaHCO3, is sparingly soluble in water in the presence of excess of carbon dioxide. So here this is a Solvay process for the manufacture of sodium carbonate. The principle. Now when a concentrated solution of brine, that is NaCl, is saturated with ammonia and then with carbon dioxide, sodium hydrogen carbonate is formed. The equation goes 2NH3 plus CO2 plus water gives NH42CO3. 2NaCl plus NH42CO3 will give you Na2CO3 plus 2NH4Cl, and Na2CO3 plus CO2 plus H2O gives 2NaHCO3. Now this sodium hydrogen carbonate thus formed is sparingly soluble in the presence of excess of carbon dioxide and is removed by filtration. It is ignited to get sodium carbonate. So 2NaHCO3 on heating will give sodium carbonate plus carbon dioxide plus water. Now the following are the steps for the manufacture of the sodium carbonate by Solvay process. The first is saturation of brine with ammonia. Ammonia gas containing a small amount of carbon dioxide is passed through 30% brine solution in saturating tank. So this is here saturating tank. Till the brine gets saturated with ammonia, the impurities of calcium or magnesium salts, if present in the brine, get precipitated as carbonates by carbon dioxide mixed with ammonia gas. So the equation goes ammonia plus carbon dioxide plus water comes ammonium carbonate, and the impurities like calcium chloride combines with this ammonium carbonate and precipitate as calcium carbonate and NH4Cl. Same goes with magnesium chloride with ammonium carbonate forming magnesium carbonate, precipitate, and ammonium chloride. So these impurities thus precipitated are removed by the filtration. Then comes second step is carbonation. The clear ammonical brine is now fed to the top of tar known as carbonation tar. So here in this diagram, this is the carbonation tar. This is the carbonation tar. Now it is packed with a number of horizontal plates, each having a hole covered by perforated plate. The ammonical brine flows down slowly and comes in contact with carbon dioxide, being admitted from the base of the tar and moving upwards through the perforation in the horizontal plates. On account of the reaction between carbon dioxide and ammonical brine, sodium carbonate and ammonium chloride are formed, and the reaction goes like this: ammonia plus water plus carbon dioxide, it is ammonium bicarbonate. And when this ammonium bicarbonate react with NaCl brine, we get sodium bicarbonate and ammonium chloride. Carbon dioxide needed in this step is prepared by heating limestone in lime kiln. CaCO3 on heating gives CaO plus CO2. The lime formed in the kiln is dissolved in the water to get calcium hydroxide, which is transferred to ammonia recovering tar and is used to prepare ammonia, that is CaO plus H2O plus will give you calcium hydroxide. Next step is filtration. The milky solution coming out of the carbonating tar contains sodium hydrogen carbonate as a fine suspension. It is filtered by means of rotatory vacuum filter to separate sodium hydrogen carbonate. Then comes calcination. The sodium hydrogen carbonate in the above step is heated strongly in a cylindrical vessel where it decomposes to give sodium carbonate, whereas the carbon dioxide released in the above process is sent to carbonating tar. And the last step is recovering of ammonia. The filtrate from the vacuum filter containing ammonium chloride is mixed with slaked lime and heated by a steam in a tower known as ammonia recovering tower, where ammonia is obtained. The filtrate also contains small amount of ammonium bicarbonate. The mixture of ammonia and carbon dioxide thus obtained in the saturator where it is used to saturate brine with ammonia as discussed above. But this process cannot be used for the manufacture of potassium carbonate. The above Solvay process is used for the manufacture of sodium carbonate. But why not for potassium carbonate? Because potassium hydrogen carbonate is fairly soluble in water even in the presence of excess carbon dioxide.